What if the real mystery was never the object, but the system behind it? For decades, people have argued about UFOs the wrong way. Are they real? Are they alien? Are they secret aircraft? But maybe that's not the right question. Because if even a fraction of the reported movement is accurate, then what we're looking at is not just an unusual vehicle. It's a different relationship with motion itself. And if that were true, the consequences would go far beyond flight. Across decades of reports, footage, and pilot testimony, one pattern returns again and again. Instant acceleration. Sharp directional changes. No visible propulsion. No aerodynamic surfaces doing what they should be doing. No normal delay between force and motion. And that matters. Because modern engineering is built on a simple assumption. To move, you push. You push against air. You push against mass. You push against the ground. You push against fuel. Force. Reaction. Motion. That's the model. So when something appears to move without following that chain, the problem is no longer just what the object is. The problem is the model itself. And this is where the story becomes more interesting. Because over the last century, there have been researchers exploring unconventional models of motion. Not better engines, not more thrust, but different interactions. High voltage asymmetrical systems. Field effects. Electrogravitic concepts. Rotating superconductors. Strong electromagnetic environments. Interacting with matter in unexpected ways. Some of these experiments were published. Some were discussed seriously. Some were replicated only partially. Some were never replicated consistently at all. And that point matters, because without replication, science doesn't move forward. So this is not a claim that these systems worked. It's something more careful than that. It's the observation that certain ideas kept appearing and never fully entered mainstream engineering. Different places, different people, different decades, same pattern at all. Interesting effects. Unclear mechanisms. No integration. Now, the easiest reaction is to dismiss all of it. And sometimes that's fair. A lot of unusual research collapses under scrutiny. Some results are bad measurements. Some are unstable artifacts. Some are misinterpretations. But dismissal doesn't answer the deeper question. Why do these ideas keep clustering around the same concept? That movement may not always be about pushing through space, but about interacting with something around the system. A surrounding field, a boundary condition, an interaction layer we don't fully understand yet. That doesn't mean anti-gravity. That doesn't mean free energy. And it definitely doesn't mean aliens. It means something much more serious. That our current model of motion may be complete enough to build civilization, but not complete enough to explain every reported edge case. And if that's true, then propulsion may not be the real problem. Energy control is. Sustaining the effect, stabilizing the interaction. Making it measurable. Making it usable. Understanding the effect is one thing. Understanding how to control it is something else entirely. This is the point where most people jumped too fast. They assume that if something didn't become mainstream, it must have been suppressed. But reality is usually more complex. Some ideas disappear because they don't work. Some because they work only once. Some because they can't scale. Some because they are too unstable to become real systems. And some because they don't fit the model strongly enough to attract investment, infrastructure, and belief. The world doesn't usually work like this. Discovery, then cover-up. It works more like this. Discovery, difficulty, confusion, neglect, forgetting. That is a much more realistic pattern. But let's go one step further. Let's assume, just for the sake of argument, that a technology based on these principles did exist. Not as rumor, not as theory, but as real, functional, repeatable engineering. Then the question changes completely. The question is no longer, would it be impressive? The question becomes, what would it break? Most people imagine one thing, a silent craft in the sky, but that would be the smallest consequence. Because a real breakthrough in non-conventional motion wouldn't just create a new vehicle. It would create a new logic of infrastructure. If motion no longer depends on combustion, on roads, on wings, on rails, on lift surfaces, on conventional propulsion, then transport changes, logistics change, construction changes, military doctrine changes, urban design changes, supply chains change, energy demand changes, material science changes, even the meaning of distance begins to change. This is why paradigm shifts are never just about one machine. They are about everything built around the old machine. A technology like this would not enter the world as a gadget. It would enter as a disruption of systems. And this is where things become more serious. Because the real danger of such a system would not necessarily be its power. It would be control. Today, society works because movement is constrained. Cars follow roads. Aircraft follow regulated airspace. Ships follow routes. Drones are limited by range, law, detection, and performance. Control exists because motion is predictable. Now imagine a system that is not constrained in the same way. No roads. No traditional air corridors. No normal interception logic. No clear propulsion signature. No obvious limit in directional movement. How do you regulate that? How do you track it? How do you stop it? You can give police faster cars. You can give militaries better aircraft. You can build stronger defenses. But if a technology levels performance itself, then the game changes. When everyone has the same speed, the same maneuverability, the same freedom of movement, control no longer belongs to the fastest. It belongs to the smartest. And that may be the most unsettling implication of all. Because in a world where performance is equalized, intelligence becomes the only real advantage. Not horsepower, not thrust, not armor, prediction, coordination, decision speed, adaptation, and eventually, I.It. If every system had similar physical capability, then whoever has the better model, the better prediction engine, the better autonomous control, the better decision pipeline, has the real power. At that point, motion is no longer the central issue. Information is. Control shifts from the physical world to the informational one, and that creates a new kind of imbalance. Because even if governments had larger systems, more sensors, better integration, more computing power, control would still never be absolute. A smaller system, perfectly tuned, can outperform a larger one. In the right conditions, a more agile intelligence can exploit what a more powerful one misses. So even in that world, power would concentrate, but control would never be complete. And maybe that is the real dividing line. Not whether a technology is powerful, but whether it can be controlled. Because history shows something important. The system absorbs what it can regulate. Nuclear weapons were integrated into the world, not because they were safe, but because they were controllable by states, infrastructures, and institutions. A truly destabilizing technology would be different. It would be powerful, replicable, hard to detect, hard to regulate, and difficult to contain. Not dangerous because it is mysterious. Dangerous because it breaks the link between capability and control. That is the kind of technology a civilization would struggle to absorb, not because it disproves physics, but because it destabilizes governance. And there is another layer that almost nobody talks about: side effects. If a system of motion relied on intense fields, unusual emissions, or energetic interactions not yet well understood, then the issue wouldn't only be transportation. It would be exposure, interference, biological effects, thought, electromagnetic compatibility, environmental interaction. Not science fiction. Engineering. Any powerful real-world technology has to pass 3 tests. Can it be measured? Can it be controlled? Can it be made safe enough to normalize? If the answer to one of those is no, then the technology does not disappear because of a conspiracy. It disappears because civilization cannot yet integrate it without unacceptable consequences. And that may be the most realistic explanation of all. Not that some systems were fully hidden, but that some ideas never became usable enough to enter the structure of the world. At that point, we come back to the original question: what are we actually seeing? And the honest answer is still the same. We don't know. Not enough to conclude. Not enough to prove. Not enough to dismiss everything either. But if some observations are real, then maybe the most important part is not the object. It is the possibility that motion itself may be less fully understood than we assume. And if that is true, then the biggest story was never about visitors. It was about limits. The limits of our models. The limits of our engineering. The limits of what the system is ready to absorb. We didn't prove these experiments changed physics. We didn't prove these craft exist. And we didn't prove that any hidden technology is waiting in the shadows. But we can say this: for over a century, the same question has kept returning. What if movement is not only about force, but about interaction? And if that question is still alive, then maybe the real anomaly is not the object in the sky. Maybe it's the gap between what we observe and what our current models are prepared to explain. And if even our understanding of motion is incomplete, what else are we missing?